Welcome to Faizan Azam Model School. In today's science class, we are going to learn about friction.
Okay, so have you ever actually stopped to think about a force that is completely invisible, yet literally dictates almost every single physical interaction in your day? I mean, what is this force that safely lets you walk down the street, but simultaneously, and kind of ironically, destroys heavy machinery over time? It's a pretty fascinating paradox, right?
Well, welcome to this explainer. Today, we are uncovering the mechanics behind this invisible force, friction. You know, we interact with it constantly, every single second, yet we rarely pause to understand its rules. So let's dive in and look at exactly how this force shapes our physical world.
Okay, let's dive into this. Here is our roadmap for today. First, we'll meet this invisible force. Then, we'll cover the 4 types of friction. Ask if it's a friend or a foe, explore how we actually control it, and finally, we'll finish up with a quick quiz to test your knowledge.
All right, starting off with section 1, meet the invisible force. What exactly is friction?
At its absolute core, friction is simply the force that resists motion between two surfaces in contact. Think of it as a physical pushback at the microscopic level. You see, even seemingly smooth surfaces like glass or metal have these tiny microscopic bumps and valleys. When two surfaces press together, those little irregularities interlock, kind of like puzzle pieces. If you try to push an object forward, friction acts in the exact opposite direction. Bottom line, no contact, no friction.
And we rely on this invisible grip every single day. Walking without slipping? Yeah, that's friction literally locking your shoe to the pavement so you can push off and move forward. Writing with a pencil? That works because the microscopic resistance tears away tiny layers of graphite, leaving a mark right there on the paper. A car stopping relies entirely on this resistance, translating all that kinetic energy into friction at the brake pads. Oh, and on a cold day, rubbing your hands together? That directly converts mechanical resistance into thermal energy, instant heat.
Moving right along to section 2, the 4 types of friction, or as I like to call them, the personalities of force.
So friction actually adapts depending on the physical situation. We've basically got 4 distinct personalities here. First up is static friction. This is the stubborn force that completely prevents an object from moving at all. It's what keeps a heavy box perfectly planted on the floor when you first lean into it. Next is sliding friction, which acts when two surfaces actively rub against each other, like when you're pushing that box once it's finally moving. Then we have rolling friction, which dictates rolling objects like bicycle wheels. Interestingly, this one is inherently way weaker than sliding friction. And finally, fluid friction. This pushes back when an object moves through a liquid or a gas. It's exactly that aerodynamic drag you feel when you stick your hand out the window of a moving car.
That brings us to section 3. Is friction a friend or a foe? Let's talk about its dual nature.
Friction honestly has a really severe dual nature. On one hand, it is an absolute lifesaver. We completely rely on it to walk, to stop our vehicles safely, to write, and just to grip objects. It's for sure our friend. But on the flip side, it's also a highly destructive villain. It causes massive wear and tear on machinery, literally shearing away material over time. It generates a ton of unwanted heat, absolutely kills mechanical efficiency, and drastically increases global fuel consumption because our engines are constantly fighting against it. It really is this constant, super expensive battle of energy loss.
And this brilliantly illustrates our fun fact for the day: ice is only slippery because it creates an environment with almost no friction. The very second that vital grip is removed, you instantly realize just how much you depend on this invisible force simply to stand upright. No friction, no balance. All right, on to section 4, how we control friction, or essentially hacking the physical world.
Because of this crazy dual nature we just talked about, so much of human engineering is just about manipulating friction. When it's a foe, causing all that wear and tear, we figure out ways to minimize it. We apply lubricants like oil or grease to create a microscopic fluid boundary. We use ball bearings to cleverly replace sliding friction with rolling friction, and we smooth down surfaces. But when we actually need friction as our friend, we actively ramp it up. We engineer deep treads into tires to channel water away and maximize grip, and we add thick, rough rubber soles to our boots to intentionally invite that resistance back in.
Which brings us to section 5. It's time for the quick friction quiz to test your knowledge.
Okay, question 1. Let's see if you remember. What are the 4 distinct types of friction? I'll give you a second to lock your answer in.
Got it? The answers are static friction, sliding friction, rolling friction, and fluid friction. Awesome job if you got all 4.
All right, next question. Can you name one engineering method we use to reduce friction and one method we use to increase it?
To reduce it, you could have said lubricants, ball bearings, smooth surfaces, or using wheels. And to increase it? Roughening surfaces, using rubber soles, or adding deep tire treads. Spot on. So, I'm going to leave you with this provocative thought. Without friction, we couldn't walk, we couldn't drive safely, or even write down a quick thought. It's absolutely crucial. So, what would your world look like if this invisible force suddenly disappeared tomorrow? I guarantee it completely changes how you look at the simple act of taking a step. Thank you so much for joining me on this explainer. Keep questioning everything, and I will see you next time.